All right, so this is Module 7, the movement of matter. So in this module, we talk about a bunch of different cycles, which will be brought up throughout the year. All the cycles are really important to remember. So these are just things that you probably just need to memorize. So the first one is the hydrologic cycle. Most people know this one. It's a water cycle. So the water cycle basically just moves water through the atmosphere. So like I said, it's pretty important. Everything needs water. So if we kind of study this, there's a bunch of terms, and the terms, I've got a bunch of vocabulary that's written out in the slides, so you guys will see that as we go through. But basically, the sun's energy comes down, causes evaporation. Evaporation goes up into the sky, then precipitation occurs, water comes back down. Water goes into the ground, so infiltrates into the ground, into groundwater, and then it evaporates again. One thing that a lot of people forget is that transpiration occurs. So transpiration is plants giving off water during photosynthesis. And that's actually pretty big. So there's quite a few plants on Earth, and they give off a lot of water during photosynthesis. So that's a big player. That's why if you go to places that have a lot of plants, like a rainforest, for example, it's wet there, but they're also giving off a lot of water, and that causes it to be very humid. Same thing with like a grassy area or just a forested area in general, tends to be more humid than a area that's less vegetated. All right, so the carbon cycle. The producers take up carbon. So if we just go through this picture here, you guys can read on the side. But carbon cycles through everything. So it cycles through the air, the ground, the water, just like the water cycle. And so it's all throughout all the different systems. So when we burn things like fossil fuels, for example, it gives off CO2 into the atmosphere. Forest fires give off CO2 into the atmosphere. And then it goes up into forms gases, maybe forms in the clouds, and then hopefully is absorbed by the plants back out of the atmosphere. It is a greenhouse gas, so CO2 is one of the major greenhouse gases that we're concerned with. So plants are a big part of that. So plants take that CO2 out of the atmosphere. Also, the oceans, a lot of people forget about the oceans, but the oceans are huge. It makes up 3/4 of the earth. And it absorbs a lot of CO2. And so when it does absorb CO2, though, it causes the oceans to be more acidic than normal. And so that can affect ocean life. So it makes things like the shells of things that have calcium carbonate shells. So any shelled creature, basically their shells become very brittle and not very healthy at all. And so that is a big factor that we look at later on in this year, is the acidification of the oceans. But going back to the carbon cycle, so things that give off CO2 besides fossil fuel burning and fires would be just respiration. So animals breathing. So we're breathing out CO2. Plants take in CO2. And then we've got, and they take in CO2 through photosynthesis. And then we've got the oceans, like I said, there is photosynthesis occurring in the oceans as well. CO2 in the atmosphere is simply dissolving into the ocean. And then it's buried into the ground, into fossil fuels, which we like to dig up and use as fuel. So that's the carbon cycle. So very important. The biggest thing we kind of are concerned with the carbon cycle is just carbon dioxide in general. All right. So moving, a little bit farther. So moving on to the nitrogen cycle. So the nitrogen cycle, this is really important for plants. So the nitrogen cycle is, without it, we wouldn't be able to have our photosynthesizers. So nitrogen is one of the key 6 macronutrients that organisms need, especially photosynthesizers. So if we look at the diagram here, nitrogen is fixed into the soil by nitrogen fixing bacteria mostly. Sometimes those are found on the roots of plants as little nodules. And they take any type of nitrogen that's in the soil. It could be ammonia, it could be nitrates, nitrites, but it takes those out of the soil and fixates them so that plants can use them. And then plants take in nitrogen. They use nitrogen for their growth. Nitrogen goes into the atmosphere, and that could be just simply being given off by the bacteria. So that goes into the air as well as the ground. And then, like we said, it can rain, it can precipitate out in the form of ammonia. And then it's given off by animals in the form of urine. So we give off ammonia. And then it's fixated by the bacteria and the plants take it back in. And this is also occurring not only on the land, but it's also occurring in the water as well. So nitrogen cycle also moves through all the different systems. So it moves through the air, it moves through the ground, it moves through animals and plants. And then, so here's just a few key terms. So nitrogen fixation just means that we're taking nitrogen gas out of the atmosphere and making it into a form that plants can use. And so one of the processes is nitrification. So you're taking ammonia and you're converting it into nitrates, which is something that plants can use. So it goes from ammonia to nitrite to nitrate. And then assimilation is basically just the fact that the plants are taking in nitrogen through the roots and fixating it into their leaves and stalks. So that's called assimilation. All right, some more key terms for the nitrogen cycle, but mineralization is just converting. So let's say that an animal dies, so that animal is decomposed and that nitrogen that animal contained or that plant is broken down and goes back into the soil. So that's mineralization. Ammonification, the decomposers are breaking down the dead and decaying things into ammonium, and then that's converted into nitrites and nitrates. And then a few other terms, leaching. I already talked about denitrification, but leaching is just going down into the soil. So let's say that the plants, bacteria are breaking it down, and then it rains, and that leaches, meaning going back down, seeping through the soil, and then maybe into the groundwater after that. All right. And then the phosphorus cycle. I need to move my picture around all over. So the phosphorus cycle, the main thing that you need to remember about this, one, phosphorus is really important for plants, but it does not move through the air. So phosphorus cycle is the only cycle that we talk about that does not go through the atmosphere. So it stays just in the oceans, in plants, in fertilizers and rocks, but it does not move through the air at all. So if we look at this, it's exposed because of geological uplift. So plates are moving around, causing phosphorus to be exposed. And then basically it's dissolved back into the ocean. Consumers, producers use it. And then when they die, it's put back into the rocks and then exposed again. And so ways that we can make it worse, I guess, would be, you can see in this picture, there's fertilizers. So using excess fertilizers, detergents, leaching into the soil, that's forming more phosphorus. So over fertilizing is a big deal. And this is also for nitrogen. So goes for both, but phosphorus and nitrogen both can be, humans can hurt that cycle as far as using too much fertilizer. So we'll talk later about that in this class. But yeah, basically phosphorus cycle is important for organisms, mostly plants, to be able to grow and be healthy. All right. And then the sulfur cycle. So another cycle, quite a few cycles in this. So sulfur cycle moves through everything. So you can see sulfur cycle is moving through the ground here. And sulfur is exposed from mining or just geological uplift in general. And then it goes into the atmosphere. And this, the sulfur cycle, if it goes up into the atmosphere, and that's mostly, naturally it's volcanic eruptions, but a lot of our fossil fuel burning produces sulfur in the atmosphere, and that can lead to acid rain. So this is our main component of acid rain. And so it gets up into the atmosphere, mixes with the clouds, water vapor, and then precipitates out. And that's very acidic and very detrimental to plants. And then organisms like amphibians and things that rely on a certain pH in the water. So the sulfur cycle can be, once again, harmed by humans. So you can see all of these things are, we can definitely play a big part in making it worse. But anyway, so the sulfur comes down. Let's say it precipitates out as acid rain, and then leaches back into the soil, gets into the oceans, and creates more acidic environment for the oceans as well. So carbon dioxide and sulfur play a big part in ocean acidification, which is basically destroying the coral right now. That's one of the main components of coral bleaching. A little bit of temperature change, but a lot of coral bleaching has to do with too much carbon dioxide and sulfur making the oceans more acidic. So that's the sulfur cycle. And so just a few terms. When we talk about biogeochemical, we talked a little bit about that in class. Bio is life, geo refers to the ground, and then chemical is just these different compounds moving through. So the sulfur, the phosphorus, the carbon, it's referring to that. So biogeochemical cycle is carbon dioxide, sulfur, nitrogen, water cycle. All of those cycles are part of that biogeochemical cycle. And then, of course, hydrologic cycle, we talked about it, but that's movement of water. So hydro means water. All right, and then the few terms that I talked about in the hydrologic cycle, we've got transpiration. That's one that people forget about all the time with plants. But transpiring, they're giving off, during photosynthesis, they're giving off water. And then evapotranspiration, it's a combination of transpiration and evaporation. So that together creates the humidity or the water vapor that's in the sky. And then runoff, of course, just, simply it's raining and the water runs off into the ground or into the ocean or rivers. All right. So then the carbon cycle, carbon moving around the biosphere. Macronutrients, I mentioned that nitrogen is one of those key elements. So the 6 main elements, this is important to remember, but the 6 key elements that are needed in large amounts, so macronutrients, would be nitrogen, phosphorus, potassium, calcium, magnesium, and sulfur. So our main cycles, though, are nitrogen, phosphorus, and sulfur. The other things are minerals that move in and out of the systems, but they're not key cycles. They are key macronutrients, but not just major cycles. They're kind of involved in other cycles. A limiting nutrient, we will talk about this a lot. So a limiting nutrient is a nutrient that is in small amounts, but it's absolutely necessary. So let's say that nitrogen, for example, I mentioned that is really important for plants. So if we have a certain amount of nitrogen, then we can only have a certain amount of plant growth before we run out of nitrogen. And so it's limiting, meaning that there's not an abundance of it, or it's not just unlimited, like however much you want, but it's necessary for growth of the plants or organisms that are there. So nitrogen is definitely a limiting nutrient. Water would be a limiting nutrient. Phosphorus is, so all these cycles that we talked about are basically limiting nutrients, but nitrogen is a big one. And then we talked about the nitrogen cycle already. All right, so looking at the phosphorus cycle, so it's moving around the biosphere. So remember that the phosphorus cycle does not go into the atmosphere. So that's the only one that doesn't. Too much phosphorus could cause algal blooms. So algal blooms, this could be because of fertilizer. Too much fertilizer is generally why we have phosphorus and algal blooms. But algal bloom is where you've got like red tide. Maybe you guys have heard of that. But we've got an excess amount of nutrients in the water, so it creates this huge amount of algae. And what happens is, you might think that might be good because the animals, the fish and stuff can eat it, but a big algal bloom blocks light from things down below. And so if that happens, then you get dead zones in the ocean. And dead zones are just areas where there's nothing really growing. Maybe the coral dies off, maybe the organisms that used to be there fish or crabs or whatever is there, is no longer there, because now you've got this algae that's just kind of covering everything. So that is generally, and that'll come up on the AP test. So they'll talk about algal blooms and dead zones. We'll talk more about dead zones later, but basically it's because of excess phosphorus. So you can see that these are all, like everything I'm talking about today, the bad things about it are all anthropogenic. So remember, that means human caused. So we are causing a lot of bad things with some of the practices that we do with fossil fuel burning or excess nutrients, and we're just not being careful. Hypoxic, that's a term to know. So hypoxic is low in oxygen. So it's just a low oxygen environment. And that is usually created by excess nutrients, like the algal bloom, for example. Algae grows because of all this excess phosphorus. Well, then when the phosphorus runs out, it's a limiting nutrient. So the phosphorus runs out, and now the algae dies because there's no more phosphorus. And now the algae, is no longer photosynthesizing. So we've got the kind of this low oxygen area, and that creates this dead zone because organisms generally, unless they're photosynthesizing, need oxygen. So if they don't have oxygen, they're not going to survive very long. So you get that dead zone. And I guess my picture is kind of blocking this. Move it a little bit so you guys can see it. All right. All right, and then the sulfur cycle. Sulfur cycle we talked about already, but the sulfur is just moving around the biosphere once again. So that's important. And that's it for Module 7. So we will spend a little bit of time reviewing those different cycles, but those cycles are really, really important. So it's something that will be brought up a little bit with the Vinogradsky columns. It'll also be brought up with the ecosystem bottles that we do, and then it will be brought up pretty much throughout the whole year. We'll talk about these and how they tie into different things. So it's really important to learn those cycles. You don't need to memorize every single little arrow, but I mean, just kind of know the process and know what causes it to change. So mostly it's human driven as far as changes go. It's a lot of humans create bad things, but anyway, so that's kind of the idea behind it. But all right, so I will see you guys next time.